Hiya. So it's the second pure thing today. We had arithmetic series yesterday. We're going to have geometric series today. And then we're not that far away, to be honest, from getting to the point where we can start doing some exam sort of practice paper, the mock of the mock, if you like, which will be fun. But before we do that, last lesson I gave you a little battleships problem to have a look at. So let's start off by solving that. I will jump to the final solution in a moment, but before I do, I just wanted to show you how to sort of get into it from the point of view. We talked about blocking out everything. We got rid of the zeros. Then I was able to put these in because we've already got one in that row and things like that. Now, having done all of that, the next thing I looked at was this boat here, because this is the only one with 4. So we've got to fit 4 somewhere. Now, the only 3 places we can fit 4 are there, there and there. And then if you look in the columns, we've got 5 bits of boat to go in this column, but only 1 there and 2 there. So for that reason, I know that I can put the big boat there. And that's what I did. And then in a moment, I'll show you my final solution. And so here it is. And you may notice that I had one moment of indecision here where I momentarily put that in the wrong place, but that was my second to last boat that I was putting in. And the key is I wasn't actually guessing that. I was just sort of made a silly error for a moment. The key to doing this sort of thing is not putting one down as a guess, unless you get to the point where you think I've got to try something and then go back, in which case you've got to use pencil and make a note between what's definite and what isn't. But anyway, hope you enjoyed that. Moving on, tomorrow we'll have a different puzzle. Here we go then. So the really nice thing about geometric series is that it's in the formula booklet, and you know that you need to use the formula booklet, geometric series, which has got in that bit of important information in there. And you know, as soon as you see something to do with geometric series, you may well have forgotten what to do, but you can look in the formula booklet and we can work it out from there. The other nice thing is virtually every geometric series question starts off with the words a geometric series. So it's not one of those where you've got to recognize that it's a geometric series that's going on. They've told you. So here's our first question. Copy it down, grab the things from your formula booklet and give it a go. And in a few seconds, I'll run it through in my way. There are 2 formula in the formula booklet, but the one we need here is the sum of the terms up to the nth term, because we've been told that we need to find the value of the sum of all of the numbers in the series up to the 8th. Now, just before we do that, just to make sure you know what sort of thing we're talking about here, geometric series with the first term 5 means the first term will be 5, and then to get the next term, because the common ratio is 2/3, you would multiply that number by 5 and 2/3, which would give you 10/3, wouldn't it? And then to get to the next one, you would multiply by 2/3 again, which would get you 20/9. So it's gradually going down because each one is 2/3 of the one before. 5 and then 3 1/3, and then what's that? 2 and 2/9. So 3.3 recurring, 2.2 recurring, and so on. It's going on. And what they want to know is if we added 5 to that, to that, to that, to the 4th term, to the 5th term, to the 6th term, to the 7th term, to the 8th term, what would it all come to? Now, we could work each one out one at a time and then add them all together, or we could use this handy little formula here, where A means the first term and R, be no surprise to know, is the common ratio. And all we need to do here is slap 5 and 2/3 into that formula. So, and also n equals 8. So we want the first 8 terms. The first term is 5, then it'll be 1 take. R is 2/3, so we want that to the power 8, and then that's all over 1 take 2/3. And you can pop that into the calculator, and as far as working goes, just make sure you've written that down as you're working, and then you can just go with the answer that you find in there. Now you notice that I put brackets around the 2/3 there just to make sure that it does the 2 to the power 8 and the 3 to the power 8 in that, and that comes to 14.4 something. Now when I mark your things, I am going to be just going with the very simple idea that every single time it's to 3 significant figures unless it says in the question. So 14.4 would be our answer to the first one. So here's your second problem. This is a really typical one, so take your time, write it down, have a good go at everything. I've thrown in the second formula for you, which you will need towards the end of it, but give it a real good go. So where I would start is I would start by making a little visual image of what's going on to just make it really clear to myself of what's happening. So I know that the 8th term is 192. I don't know the 7th term. I don't know the 6th term, or the 5th, or the 4th. I do know that the 3rd term is 6, and then that will be the 2nd term, and then the 1st term, which we call A, don't we? And we want to know the common ratio. So the common ratio being the number that you multiply by each time. Now how many times are we going to do this? 1, 2, 3, 4, 5 times. So we can make an equation. This common ratio is going to be 6r. 6 times r to the power 5 is going to equal 192. So if we divide by 6, we get r to the power 5 is going to be 32. And then if we do the sank root, or whatever it's called, we would get 2, wouldn't we? And notice they've given us an odd number of those, so it couldn't be a negative. It would have to be that. Although quite often the common ratios are negative. So there could only be one thing that it could be. So the common ratio is going to be 2. So that's our first part. Next up is the first term. Well, I can just look here. You may have done this a different way, and I know that I'm timesing by r twice. So I could just divide by r twice. Now we know that r is 2. So 6 divided by 2 equals 3. Divide that by 2 equals 1.5 or 1.5 or 3 over 2. Part C, the sum of the first 15 terms. Well, for that we are again going to be using our formula from here. So we've got the sum of the first 15 terms is going to equal A, which is 1.5, pop into brackets, 1 take 2 to the power 15, all over 1 take 2, which means dividing by -1, doesn't it? And if we chuck that into the calculator, you should get 49,150.5. And then we get the last question, which is find the sum to infinity of the series. And actually, you can only do that if your r, the magnitude of r, is less than 1. So it could be between -1 and +1 without being, but it can't be anything other than that. So our r is actually 2. So we can't do that because this is an ever-growing series. So a little bit of a trick one for you there, folks. Okay, we will have a go at one of those later. Right, next problem then, and this time I promise you, you can use your sum to infinity formula. Pause the video and give it a go. So we know that the sum to infinity is -3. So I'll take that and I put, instead of sum of infinity, I'm going to put in -3. And then what does the formula say? It says a divided by 1 minus r. And I know a because a is the first term. So it's -5 over 1 take r. So all we need to do is solve this equation. Begin by multiplying both sides by 1 take r. -3 1 take r equals -5. Make sure you get a mark. Then watch out for your negatives here. We could actually just divide by -3 straight away, couldn't we? And then say 1 take r is going to be a negative divided by a negative is a positive, so 5/3. Add r to both sides and take 5/3 would be -2/3 equals r. I make that. And you can obviously sort of check it still works by popping it back in there, but that should be absolutely spot on. Right, here's the first two parts of our next example. Write it down, take your time, pause the video, give it a go. So starting off, set it up as would do before by saying, right, the second term is 80. So I don't know the first term yet, could call that a, couldn't I? And then the third term, don't know. Fourth term, don't know. Fifth term, 5.12. So the common ratio is going to be what we times 80 by to get to there, times it by r squared to get to there in one go, and to get to there in one go we would multiply it by r cubed. So we can say that 80 r cubed is equal to 5.12. Now the numbers might not be that nice, but I'm sure it should all work out quite nicely. So then we can say r cubed is equal to 5.12 over 80. So r is going to be the cube root of 5.12 over 80. Chuck that into the calculator and it gives you 0.4 or 2/5. So the common ratio is 0.4. So if I make that a there, then we'll change colour to find the first. Well, the first term is going to be, well, the first term multiplied by 0.4 would get you 80. So we could say for part B that 0.4a equals 80. So then all you've got to do is 80 divided by 0.4, which is the same thing as 80 divided by 4/10, which is the same thing as 80 times 10 over 4, isn't it? So it goes into there, 20. So that should give us exactamundo 200. The third part, pause it and have a go at this. There will be another part coming up in a minute. The sum to infinity of the series, giving your answer with an exact fraction. So let's just start off by getting the formula and plugging stuff in. So we want the sum to infinity. So we take a as 200 and we divide it by 1 minus 0.4. So that is 200 divided by 0.6, isn't it? Which is the same thing as saying 200 times 6/10 turned upside down is 10 over 6. So that would give us, well, we can certainly go to 3 and 100 there, can't we? So that's going to give us 1000 over 3. And that is an exact fraction, but I think I'd prefer to do it as a mixed number, which is another way of writing an exact fraction, isn't it? 333 and 1/3. Now here's your final part. So pause this and give it a good go. It's just one part at a time. So we've already worked out the sum to infinity of the series. It's 333 and 1/3, and we're going to need the difference between that and the sum of the first 14 terms. So let's just, showing our working, find our sum of the first 14 terms first of all. So the sum of the 14 is going to be A being 200 times 1 take 0.4 to the power 14 all over 1 take 0.4. I'm just going to write 0.6 there and chuck that into the calculator, and that has given me 333.3324. It's a little bit less, isn't it, than 333 and 1/3, which is what we'd expect because we want it all adding up to it. So how do I get the difference between that and that? Well, I'm just going to put 333 over and 1/3 in, but I'm just going to do it as 1000 over 3, and then I'm just going to press, then I'm going to come out of the fraction and press take and shift answer to get that up there, and that'll give me the difference, won't it? So, and indeed it's done it straight away into standard form as they've been asking for. So 8.94, so if we do that to 3 significant figures, it'd be 8.95 times 10 to the negative 4. Right, and that is just about all we've got time for today, other than for you to go away and do some practice. So there's all the Maths Genie worksheet there for you to have a go at. Don't worry about the first question, the proving one. We're not too fussed about that, but all the others, the questions 2 to 6 I think it is, give those a go, and don't forget to post me your evidence of how you're getting on with it and ask me any questions if you're stuck at all. Cheerio then.